Correlation statistics. Objective and assumption. Objective is correlation is by bivariate analysis that measures the strength of association between two quantitative variables and the direction of the relationship. Assumption. The assumption is for a Pearman correlation. Each variable should be continuous, interval or ratio scale, and the distribution should be normal distribution. If one or both of the variables are ordinal in measurement or continuous variables with non-normal distribution, then a Spearman rule correlation could be conducted instead. Results interpretation. In terms of the strength of relationship, the value of the correlation coefficient value varies between +1 and -1. A value of +(-1) indicates a perfect degree of association between the two variables, as the correlation coefficient value goes towards 0. The relationship between the two variables will be weaker. The direction of the relationship is indicated by the sign of coefficient. A plus sign indicates a positive relationship, and a minus sign indicates a negative relationship. When one variable increases as the other increases, the correlation is positive. When one decreases as the other increases, it is negative. And here is the example research article. The study is about the relationship between corneal deformation amplitude and optic nerve hair structures in primary open-angle glaucoma. Table 3 shows the relationship between the corneal deformation amplitude and various optic nerve hair parameters. The corneal deformation amplitude was positively correlated with parapapillary atrophy area, and R value equal to 0.385 and P value equal to 0.014, and negatively correlated with LC depth, which has R value equal to -0.369 and p-value equal to 0.005, whereas it was not significantly related with LC thickness, which has R value equal to -0.223 and p-value equal to 0.095. Thank you.
So regression analysis is a form of predictive modeling technique which investigates the relationship between two of variables. So the first variable is dependent variables and the independent variables, or the y variables. So the benefits of using this analysis is, firstly, to indicate the relationship, the significance of relationship between both variable, and the second one is to indicate the strength of impact of the independent variables on the dependent variables. And there are two types of regression analysis. First one is the linear regressions and logistic regressions. So how different of these two? Firstly, the difference is the dependent variables is for linear regression is continuous, but in the dependent variables in logistic analysis is like the categorical, usually binary, which means that there will be two choices of the result. For example, like die or alive, yes or no, boys or girls. And the other difference is for linear regressions, it's used to predict the value, which means the continuous variable, but the logistic regression is used to predict the probability that dependent variable will show the membership to the independent variable. So as you can see in the graph here, the linear regression will show as a linear line. So the value, it can be exceed 0 and 1. So it can more than 1 or it can be less than 0. But in logistic regressions, the predicted dependent variable only just in the range of 0 and 1.
And this is an example of research article. The title is Logistic Regression Analysis of Graduate Student Retention. Logistic regression analysis was used to predict the retention of 477 master and 124 doctoral candidates at a large Canadian university. Selected demographic, academic, and financial support variables were used as independent variable, and the dichotomous dependent variable was whether the student successfully completed the degree. And this is the table showing logistic regression of student retention at the master level. For the result interpretation, as the length of time in the program increased, the odds of graduating with a master degree increased by a factor of 2.88, and for the graduated GPA, as the graduate GPA rise, the odds of completing the degree increased by a factor of 2.12. And as was the case with length of time in the program and graduate, the odds of completing the degree increased as the value of funding rise.